Okay, in the exercises 3 and 4, decide whether there's enough information to prove that P is parallel to Q. If so, state the theorem you would use. Guys, in the first one, is there enough information there? Alexis?
Corresponding.
Very good. They are corresponding angles and they're shown that they are congruent, right? You guys remember this mark? It means that those two angles are congruent, okay? If you didn't know that, write it down. This is a congruence angle mark. So it means that these two angles are congruent. If we know that corresponding angles are congruent, what theorem can we apply to say that these two lines are parallel? Cody?
Corresponding angle of congruence theorem.
Very good. You're missing a part though. It's the converse. Corresponding angles theorem converse. Okay? Were we told that P was parallel to Q? Were we told that P was parallel to Q? No. We were asked to determine whether we had enough information to say that. Do you guys see that? So we can say this by the converse theorem, by the corresponding angles converse theorem. Benji, does that help for that one?
Yeah, because I was going to ask what the half circle was.
Oh, what the arc symbol means? Okay, so like in number 4, it's saying that this angle is congruent to this one. Okay? Is there enough information in number 4 to say that these are parallel? If you're saying yes, what theorem? No, they're not vertical. Jaden?
Same side interior.
Same side interior, they're not same side interior. They're not alternate exterior. Alexis?
They're not, they're like, it's like, you can't prove it.
These are not parallel. Okay? Guys, this is an exterior angle up here. And this is an interior angle. Do you guys agree? Because it's inside of our box versus outside of our box. Now, question. The only one that takes an exterior and matches it with an interior is corresponding. Do you guys agree? But are these corresponding? No, they're flipped over the transversal. Do these have any sort of relationship? No. Them being congruent does not prove that these lines are parallel. There's no theorem we could apply here, okay? Now, if you wanted to, just assign them some sort of value. So let's say this one was 60 degrees. That means that this one's congruent, so this one has to be 60. Do you guys agree? Fill in the rest of your angles. What would this angle next to this 60 have to be? 120. What would this angle next to this 60 have to be? 120. Now just look at it. Do you guys agree this angle is corresponding with this one? And this one's corresponding with this one? Technically, they're lined up to be corresponding. Do you guys agree?
Yeah.
And corresponding should be congruent, right? Are these guys congruent? No, so you know that this is not going to work. These are not going to be parallel because their corresponding angles are not congruent. However you want to look at it, right? You can look at it this way. You can look at it, okay, those angles have no relationship. Them being congruent does not prove parallel, but you need to know this, okay? I know we tested on this. It will show up in second quarter again, okay? Last minute questions on the warm-up. We're Gucci? Okay. I want to start off today's lesson with a little hypothetical situation, okay? I'm in a race, and I'm running to the finish line. And the finish line is that wall over there, okay? I have a question for you guys. If I were to run to that door, would that be faster than running to that door? Yeah. Remember, that entire line is my finish line, right? Would running to this door be the faster route, or would running to that door be the faster route?
That one.
You guys agree it's that door?
Yeah.
Discuss why. Go.
Because if you were going there, you'd have to go more in an angle.
Okay, bring it back. I heard shortest distance. Who said shortest distance is this way? You would be correct, okay? Why is this shorter though than going over there? Yeah?
Because that's at more of an angle.
It's at an angle, okay? So imagine that there's a line across the finish line, right? That wall is a line. Look at the angle that I'm about to make with the finish line. What kind of angle do I make?
Straight line.
No. What kind of angle?
90.
What? What?
90.
90.
Right.
That means these two lines are what? Perpendicular. Okay? That's our first thing that we're doing today. The distance from a point to a line is the perpendicular segment to that line. Okay? So if you're running a race, the fastest way to get to from point A to point B is to run perpendicular to the line that you're trying to cross. Yes?
Are we running this lesson, and then are we going to take a quiz?
You're going to take a quiz on this in quarter 2, yes. Homework and stuff is still counting for quarter 1 though. Okay? To a line is the length of the perpendicular segment from the point to the line. It is the shortest distance between the point and the line. Just like you guys said, it's the shortest distance, okay? Now, if I was lined up back here, guys, which now would be the shorter door to get to? This one or that one? You see how it makes a difference where I line up? Okay? Okay. One direct application of this is when we talk about the altitude of like an airplane or the altitude of anything, okay? I want you guys, we are going to draw a little bit, okay? Do your best to draw an airplane. It's going to be better than mine, I can already guarantee it, okay? It's not that bad, guys. It was better than C periods. Yikes. Actually, it's pretty bad. Okay. And here's the ground. Now, if you were to measure how high in the sky this airplane is, how would you measure it? Who said distance? Yeah, it's distance. But more specific. Like if you wanted to like draw a line, how would that line look? Yeah?
Well, I was going to say in miles. But
Yeah, you could use miles, feet. A lot of times they use feet for altitude. Yep. Up and down. What do you mean by that? Like a straight up and down line. So draw a dotted straight up and down line. What is true about this line? What is true about this line? Because this is what we consider the altitude of an airplane, right? But what makes altitude consistent? What? Yeah, it makes the level of the plane. But what makes it consistent no matter where that plane is in the sky? What's perpendicular about it? It's perpendicular to what, John?
The ground.
The ground, okay? Anytime you calculate the altitude of an airplane or anything, it's the perpendicular line straight down to the ground. Because if you created it at an angle, you'd be inconsistent and we would have no idea where airplanes were located, okay? They use this all the time because could you imagine flying in a plane and hitting another plane? It'd be devastating, okay? So they use altitude all the time, especially like airlines, to make sure that the planes don't cross the same path. So they just have one fly higher and the other one fly lower, okay? This is super important because if this was at an angle, then they would have no idea if the planes were gonna hit. It has to be a straight down line perpendicular with the ground. Very good, okay? All right, next. We're gonna do a little example, okay? We wanna find out what the distance is from point A to the line BD. So point A is over here, and we're trying to figure out, okay, how far away is that from AD, the line? Okay, now, the distance from a point to the line is always gonna be the shortest distance. What segment represents the shortest distance and why? Ronnie?
C.
C is a point.
Oh, so AC.
AC. Why, Ronnie?
Because it's the box says perpendicular.
It's perpendicular. Do you guys see that? So AC is going to be the shortest distance. This is going to be our distance from this point to this line. Does that make sense? Do you guys agree that AB is at an angle and AD is at an angle? You don't want those. You want the one that's straight down to that line, perpendicular with it. Got it? Okay. Does anyone remember how you find the distance between 2 points? What is it, Cody? It's the square root of, Mario? X2 minus X1. Square it. Yep.
Oh,
Mario. That was next level. That was next level. Okay, this is the distance formula, people. Okay? Mario's built different. Okay? This is the distance formula. Okay. We have to use the distance formula to find the distance between A and C. Now, does it matter what I label my points, X1 or Y1? No, but you have to label one X1, Y1 and the other one X2, Y2. I always do A is lower in the alphabet. This is going to be my X1 and my Y1. C is later on in the alphabet. That's going to be my X2 and my Y2. Okay, that's just how I do it. You can do it the same way. You'll get the same answer if you reverse them though, okay? Just so we're all clear. What do I do once I've identified my X1, my Y1, my X2, and my Y2? Plug it in, okay? So it's gonna be X2. What is X2? It's 1, so we're gonna do the square root of 1 minus, what's X1? It's -3. So a minus a negative. Make sure there's 2 negatives there. Then we're squaring it. And we're adding it with y2, which is what? -1 minus, what's y1? -3, and then you're squaring it. So we're going to get AC equals the square root. What's 1 minus a -3? 4. And then we're squaring it. Plus... what's -1 minus 3, John? -4. And then we're also squaring that. Guys, what is 4 squared?
16.
And -4 squared?
Positive
16. 16 plus 16. Okay, watch. AC equals the square root of 32. If you were to leave your answer like this, I'd be happy but not completely satisfied. Because you can simplify this. The people who had me for algebra last year, I know you know this stuff. We're looking for a perfect square that's a factor of 32. John?
4 on the outside and 8 on the inside, like the box?
Nope. Wait, 4 and 8, yes, those are both factors. But there's a higher perfect square that's a factor of 32. John?
16.
There we go. Break this down into the square root of 2 and the square root of 16. Do you guys agree 16 times 2 is still 32?
Yep.
So we haven't changed it at all. Which one's the perfect square, 2 or 16? 16. What's the square root of it?
4.
So AC is going to be equal to 4 times the square root of 2. We're done. Now, if John did 8 and 4, right? 4 is a perfect square, would pull out a 2. But 8 you could also break down into 4 and 2 again, right? Pull out another 4, you'd get 2 times 2 on the outside, which is 4, times the square root of 2. So it's fine if you don't do the largest perfect square, but try to look for the largest perfect square that you can pull out. What's up, John?
Wait, how do you know which number goes on the inside and which one goes out?
Whichever one's the perfect square. So you agree the square root of 16, we know that it's 4, so we're going to take it outside of the square root. Okay? Because the square root of 16 is 4. You can write this. Equals 4. But the square root of 2, it doesn't have a perfect square, so we're going to leave it as the square root of 2. Okay? Yeah, Carson? Yes, you may.
Wait, is it 4 perfect square also?
4 is a perfect square, but if it's not underneath the square root, don't take the square root of it. Got it? Okay. Good questions. Any other questions? Peeps. I want you guys to go to the next slide. And I want you guys to talk for about 1 minute. If two lines intersect to form congruent adjacent angles, what do you know about those two lines? You may want to draw a picture. You have 1 minute to discuss. Go. Time. Does any group think that they got it and can explain why? John?
They have to be perpendicular and they're like a linear pair, and if it was like complementary, it had to be 45, like both each, and then if it was supplementary, it had to be 90.
Very good. Okay, did we hear what John just said? So, draw two lines that intersect. Draw two lines that intersect. What does it mean to be adjacent?
Share vertex.
Yeah, share a vertex, but not just that. Yeah, John?
No linear pair.
Two angles.
Yeah, linear pairs are adjacent, but adjacent's more general. What does adjacent mean, guys? Yeah? What?
Together?
Like next to each other, right? So if this angle 1 and this angle 2, do you guys agree that they're right next to each other? They're adjacent, they share a side and a vertex. If these two have to be congruent, how did John know that they had to be 90 degrees each? Sophia? But why? What's a bisector? It cuts the line in half, right? So if angle 1, the measure of angle 1, must be equal to the measure of angle 2, they both have to be 90, because 90 plus 90 gives me what? 180. And we know that that is a straight line. They're a linear pair. So we can just put our 90 degree angle mark for all four of these. Does that make sense? A little bit? We just proved our next theorem. Yours is this slide as the next one? Okay. A perpendicular bisector. Stop writing. Stop writing. First off, what does it mean to be perpendicular? What? 90 degrees, okay? Look at this image. Do you see how there's a 90 degree angle mark? What does it mean to be a bisector? Cuts it in half. So do you see how the line N is cutting it in half and making it a 90 degree angle? Perpendicular bisector. Two requirements. Write it down now, okay? The perpendicular bisector of a line segment, PQ, is the line N with the following two properties. It must intersect at a 90 degree angle. In other words, it must create a right angle. And it must pass through the midpoint. It must split that line segment into two equal parts. Why isn't it? Okay. Our next theorem is the linear pair perpendicular theorem. And it says just that. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So if the angles next to each other, when two lines intersect, if they're congruent, then they must be perpendicular lines. Is this any of yours? Next one, perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. If H is parallel to K and J is perpendicular to H, then J must also be perpendicular to K. What that's saying is, we've basically covered this before, okay? If we have two parallel lines cut by a transversal, if there's a 90 degree mark anywhere on this guy, then the other one has to be 90 as well, okay? They both have to be perpendicular. I mean, think about it. Aren't two parallel lines facing the same direction? So if a line cuts them, they should have the same angles everywhere, right? So therefore, they both must be perpendicular, okay? Now, is it necessary for them to be coplanar? The answer is yes, and I drew a picture over here. Do you guys see these two parallel lines? Do you guys agree that if I took my Apple Pencil and I put it like this, and I told you it was 90 degrees with one of them, it would have to be 90 degrees with the other one? Now, imagine if they weren't coplanar. So if I moved it like this, is this Apple Pencil now perpendicular to one of the lines?
Yeah.
It is still, right? But is it ever going to hit the other line?
No.
No. Do you see the difference? So it could be perpendicular to one and not hit the other if they weren't in the same plane. So part of this is that they need to be in the same plane. Got it? Okay. Next, we just reversed the order here. So it says if they're both perpendicular to the same transversal, then what do we know about those two lines? They're parallel, okay? So if they're both perpendicular to the same line, to the same P, the line P, then they must be parallel to each other. So M and N must be parallel. It's very, very similar to the transitive property. Only in our last statement, we're not saying that they're perpendicular to each other. We're saying that they're parallel to each other. Example 2. Oops. A photo shows the layout of a neighborhood. Determine which lines, if any, must be parallel in the diagram and explain your reasoning. Okay, you may want to zoom in so you can see it a little bit better. Does anyone think they know one pair of parallel lines in the diagram? Sophia? P and Q. Very good. P and Q is a pair of parallel lines. Very good. Why do P and Q need to be parallel? John?
They both have right angles.
But where?
All the way on the left on line S.
Very good. So watch this. We can say, bye, Kristen. Have a good weekend. P must be parallel to Q because P was perpendicular to what line?
P is perpendicular to line
S. And,
T.
wait, what?
T. And T.
No, P isn't perpendicular to T.
Yeah.
No, it's not.
Yeah, there's a right angle at the bottom.
No, Q is perpendicular to T.
Yeah, but doesn't that line still continue? Or?
Yeah.
Oh, eventually, yeah, we could say that. But let's just say P is perpendicular to S and Q is perpendicular to S, right? Do you guys agree that Q down here is perpendicular to that line S?
Yeah.
Because of this 90? We're focused on these two guys. Do you guys see that? I feel like I lost some of you. Do we all see how those two lines are perpendicular to the same line S? Now remember, if two lines are perpendicular to the same one, what do we know about those two lines? P must be parallel to Q. Do you guys see that? All right. Is there another pair of lines that's perpendicular to the same line? Sophia? Very good. We can say S is parallel to T because S is perpendicular to what?
P.
Yeah. Wait, no. Well, it is perpendicular to P.
From Q.
Let's say Q. And T is perpendicular to Q. So therefore, take out your middle man. S must be parallel to T. Sophia, does that make sense? Macy, you with me? Benji, how we doing? You good?
Yeah.
Okay. Okay, one more. The diagram shows the layout of walking paths in a town park. Determine which lines, if any, must be parallel in the diagram and explain your reasoning. Cody? A and B must be parallel. Do we agree with Cody? I do. Hayden, do you know why?
Because they are corresponding.
Ah! They're corresponding. So we can use the corresponding angles theorem.
Congruent.
No.
Wait, what?
Converse.
I don't know.
Okay? But now we also learned a new theorem. And it says if they're both perpendicular to the same line, then they're parallel. What line are both A and B perpendicular to?
D.
D. Okay? A is perpendicular to D. And B is perpendicular to D. Therefore, A must be parallel to B. Please make a note of how I'm writing my answers. You cannot just say A and B are parallel. You have to explain it by saying that they're both perpendicular to the same line. Okay? Then you can say that they're parallel.